Percentages will be used extensively in other math topics, so we need to review it extremely carefully. Let's jump in. So percent means per 100, which means divided by 100. When we say 30%, it is 30 divided by 100. So let's say if I say 55%, we can write this as 55 upon 100. Percentages are just like ratios. So they give us relative values between quantities. And when there are two quantities, the percentages and the ratios become interchangeable. All right, so what do we mean by that? For example, if I say that 30% of students in a class have red hair, what does this mean? It means that 3:7 is the ratio of students who have red hair and who do not have red hair. Do not have red. So they could have hair of any color, doesn't matter. But the point is that the ratio of the students who have red is to who do not have red is 3:7. Yeah, or we can say the ratio of the students who have red hair is to the total number of students. So we can say red is to total, that is equal to 10. Basically, they both percentages and ratios give us the same relationship. They tell us what is the value of one quantity as compared to another. They don't really give us the actual values. How many students are there with red hair in that class? We do not know. All we know that out of 10, every 10, 3 have red hair and 7 do not have red hair. So if we are given 30%, we can get this ratio of 3:7. And if we are given this ratio 3:7, we can get the percentage of 30% have red hair and 70% do not have red hair. All right. So then if percentages and ratios are interchangeable, why do we use percentages? Let's say if I say that A took 2 tests and scored 60 out of a total of 100. And I say B took 2 tests and scored, let's say 100 out of a total of 300. Now, who performed better? It's hard to compare, right? It's hard to compare the whether 60 out of 200. This is 200. He took 2 tests. So it's hard to compare that whether 60 out of 200 is better or 100 out of 300 is better, right? But we can say that if A scored 60 out of 200, that means out of 100, how much did he score? If A scored 60 out of 200, then out of 100, if this halves, this will also become half. So then A scored 30 out of 100. And here we say if B scored 100 out of 300, then out of 100, how much did he score? If this has become 1/3, this will also become 1/3. So this is 33.33. This means that the percentage of marks of B is 33.33 and the percentage of marks of A is 30. And now it's really easy to compare the two. We can easily see that 33.33 is more than 30. So if we are given that A scored 30% and B scored 33.33%, then it is very easy to compare their marks. Hence, percentages are often used for the purpose of comparison, to compare two different quantities, two different parameters. If we put them in terms of ratio, if we put them in terms of percentages, we directly get to see which one is greater, which one is smaller. Okay, so here, this is how we calculated the 30. We use the concept of ratios, that if this becomes half, the multiplier is 1/2 here, then the multiplier is 1/2 here also, and this also becomes half, and this becomes 30. When we use it in terms of percentages, it's the same. Of course, conceptually it's the same. The answer is everything is same, but we show it differently. We say 60 upon 200. He got 60 marks out of a total of 200. And if we want to put it in terms of percentages, we multiply by 100. And then what we get is 30, of course, right? This gets cancelled, we get 30. So this now we say is in terms of percentages. Look, this is nothing but the same thing, right? Here we have taken 100 to the left-hand side and multiplied it. So what we'll get is 30, the numerator of the right-hand side. we use this representation in ratios and we use this representation in percentages. When we want to convert something into percentages, we multiply this into 100. So 30% of 300. Now, if we are given a percentage and we want the actual value, if I have to say that I know that A scored 30% marks, but his total marks were 300, how do we get the actual marks of A? We will say 30%, which means 30 upon 100 of 300 into 300 will give us 90. Again, look at this. This is the same representation as ratios, right? In ratios, we say 30 upon 100 is equal to 90 upon 300. So we have just brought this over here and we get this 30 upon 100 into 300. So this is how we represent percentages. We say 30% of the base. Your base is the actual value of the total. So just saying 30% doesn't make any sense. We say 30% of what? There has to be a quantity. There has to be a total for us to get the actual value. So we represent this as 30% of base. Now this will become a lot more clearer once we go to examples. 20 is what percent of 40? Now, this can get a little confusing because what is 20% of 50? 20 is what percent of 40 or 50? Then 20 of what number is 50? So we should be able to put it in an equation accurately. Hence, we have an easy method to do that. We say 20 is, for is, we use equal to, because we are saying 20 is equal to, right? Is only a short form for is equal to. So 20 is equal to what percent? Now, we don't know what. This is what we have to find out. So we'll say X. What percent? Percent is 100. So what percent of 40? Of stands for multiplication of 40. So this is our equation where we say 20 is equal to what is the unknown X. Percent is 100, of is multiplication, and 40 is your 40. Now you can get the value of X. Let's try out and write the equations for everything. 40 is will be equal to what percent? What is X and percent is 100. Of is multiplication and 20 is 20. Again, we can get the value of X. What is what? So X, what is what? What I mean to say is, this is X. Is equal to 20% is 20 upon 100. Of is into, and 50 is 50. Okay, 20%. So 20% is 20 upon 100. Of is multiplication. What? What is X? What number? 20% of what number? What number is X? Is equal to, and 50 is 50. Okay. 180 is 40%, 40 upon 100 of is multiplication. What number? X. So this is how we'll convert each of these statements into an equation, and now we can easily solve for X. So we discussed that percent is per 100. So when I say 60%, that is equal to 60 upon 100. And if I were to simplify it, I would say that this is equal to 3 by 5 in its simplest terms. So using 3 by 5 for calculations is much easier. Let's say if I have to find 60% of 25, for example. So 60% of 25, I can write this as 3 by 5 of 25 and then I directly get my answer as 15. So just that these percentages are simplified into their lowest forms and we get the fraction equivalent. So 60% is equal to 3 by 5. Now, you may not see a lot of value in learning these up, but when we come to increasing or decreasing a number by a certain percentage, then these equivalents come in very, very handy. So, it'll be really good to learn up these fraction percent equivalents. So this we know 50% is half, it is 1 by 2. Then if I divide both the sides by 2, we get 25% is 1 by 4. Again, something that we know really well. Now, if we multiply this by 3 on both the sides, we get 75% is 3 by 4. This gets multiplied by 3 and we get 3 by 4. And if we divide this by 2 on both the sides, then we get 12.5% is 1 by 8. Now, this is something which may not be intuitive. For example, if I see 12.5% written somewhere, I may not think that this is 1 by 8. But let's say if I have 12.5% of 64, that is going to be a tough calculation, right? If I say 12.5% of 64, then you're going to say 12.5 upon 100 into 64, and this is going to be a bit of a tough calculation. But if you do realize that 12.5% is nothing but 1 by 8, then suddenly the calculation becomes extremely easy. It is very important to remember this fraction percent equivalent. Okay, now when we multiply this on both sides by 3, we get 37.5% is 3 by 8. And when we multiply both sides by 5, we get 62.5% is 5 by 8. Of course, when we multiply this by 2 on both the sides, we get 25 is equal to 1 by 4, which is just this one. When we multiply this by 4 on both the sides, we go back to this, we get 50% is 4 by 8, which is nothing but this one. Then in case we multiply this by 6 on both the sides, then we get 75% is 3 by 4, which is nothing but this one. So, which of course, these are far easier for us to remember because we might have used them, and these are a little less intuitive, this one, and this one. So make sure that you memorize all three. Then we know that 20% is 1 by 5. Of course, when we multiply by 2 on both the sides, we get 40% is 2 by 5. By 3, we get 60% is 3 by 5. And by 4, we get 80% is 4 by 5. Again, something that we might have used now and then. 33.33% is 1 by 3, we know. When we multiply both sides by 2, we get 66.6666, whatever. So we rounded off to 66.67%, which is equal to 2 by 3. And now when we divide this by 2 on both the sides, we get 16.67% is 1 by 6. Again, one of those percentages which we might think are hard to work with, but 1 by 6 could be extremely easy to work with. So it's a good idea to remember this. Now, what I like to think about is 1 by 6 is nothing but you take 1 here, you take 6, and then you say 6666%. So that's how I like to remember this. Now, when you multiply this by 5, you get 83.33% is 5 by 6. Again, something that you would like to remember. Now, 1 by 7 is 14.28%. Quite fortunate, right? Because 7 twice is 14 and 7 4 times is 28. So I like to remember it this way. 1 by 7 is, I'll twice it, it becomes 14 and I'll make it twice it again. I would just say I'll twice it again and I get 14.28%. These are just small tricks to help you remember these fraction percent equivalents. Okay, 11.11% is 1 by 9 and 9.09% is 1 by 11. So they, kind of the opposite of each other. So again, it will be helpful to remember. So make sure that you memorize these percent fraction equivalents. In the next 2 pages, we'll see how useful they are. Now let's see how the fraction percent equivalents really help us. So if 450 is increased by 10%, what do we get? How are we going to calculate this? We say 450 is increased by 10%. 10% of what? We said that 10% is always going to be of something, right? There is going to be a base of 10%. We can't say just 10%. So 450 is increased by 10%. So this 10% is of the same 450, because 450 is the one which is increased by 10% of 450. So first we are going to find the 10% of 450, and then we are going to add it to 450 to get the increased value. All right. So look at what we're doing over here. We are finding out the 10% of 450, which is 10% is 1 by 10. And then we're saying 450 plus 1 by 10 of 450. So essentially, we are multiplying 450 by 11 upon 10. When we increase a number by 10%, we are basically multiplying the number by 11 by 10. So instead of following two steps of first finding out the 10% of the number and then adding it to the number, we can simply multiply the number by 11 by 10. 11 by 10 is equivalent to an increase of 10%. Note that this fraction is greater than 1. So when we multiply a number by a fraction which is greater than 1, it will increase the value of this number. So that is why here we are increasing this number by 10%. Now, similarly, we can also, let's say, decrease a number by 10%. When we decrease 450 by 10%, how are we going to do that? The base is again going to be 450. So we'll say 450 minus 1 by 10 of 450, because 10% is 1 by 10, which gives us 450 multiplied by 1 minus 1 by 10, which is nothing but multiplied by 9 by 10. So our multiplier, in case we want to decrease 450 by 10%, will be 9 by 10. So we'll multiply 450 with 9 by 10, and this will decrease the value of 450 by 10%. Now, similarly, we can find out the multipliers in various cases and then increase or decrease a number using a single step only. Here it is fairly simple to calculate the 10% of 450, so you might not see the value in multiplying by a single fraction, but soon enough we will. Let's look at these questions. When 440 is increased by 27.3%. So first of all, I'm not really sure what is 27.3%. So I'm going to think about it. 27 reminds me of 9, right? So note that this is 9.09%. It is one of our basic fraction percent equivalents that we learned, right? So this is equal to, which we know, 1 by 11. So when I multiply both sides by 3, I get 27.27%, which is almost 27.3%. We can round it off to 27.3%. And we get 3 by 11 over here. So 27.3% is actually equal to 3 by 11. Now, when 440 is increased by 27.3%, we do not need to find 27.3% of 440. We need to increase 440 by 27.3%, which means that first we'll need to find 27.3% of 440 and then add it to 440. Or, as we discussed previously, we can simply multiply 440 by 1 plus 3 by 11. Look at this, 1 plus 1 by 10, because it is 450 plus 1 by 10 of 450. So using the same concept here, we'll say 440 plus 3 by 11 of 440. So we can simply multiply 440 by 14 by 11. Now note that this becomes a whole lot easier. This is equal to 560. Instead of this, for example, if we had to do 440 plus 27.3% of 440, well, this does seem to be a calculation that is much harder to do, isn't it? So that is the reason why fraction percent equivalents help us, especially when we are increasing or decreasing a number. We just find the multiplier that we need to use, and then getting the increased or the decreased number is quite easy. Remember that when we are increasing a number, we are multiplying by a fraction which is greater than 1. And when we are decreasing a number, we are multiplying by a fraction which is less than 1. Okay, let's go on to the next example. What is the percentage change in A when it is multiplied by 3 by 10? Okay, so when we say A into 3 by 10, how has the value of A changed? By what percent has it changed? Now, this is the multiplier, the single step multiplier that we obtained above as 11 by 10 or as 9 by 10 or over here as 14 by 11. Right? When we increase or decrease for 40, we multiply it by 14 by 11. So this is that multiplier. Similarly, here, that multiplier is 3 by 10. How do we obtain this? We either add 1 and a fraction, or we subtract a fraction out of 1. Like here, we added 1 plus 1 by 10, and here we subtracted 1 by 10 from 1. So that is how we obtain this single multiplier. So when we are multiplying A by 3 by 10, how would we have obtained it? This we would have obtained by 1 minus 7 by 10. That is what is going to give us 3 by 10. So essentially, A into 3 by 10 is nothing but A minus 7 by 10 of A. That means when we decrease A by 70%, then we get 3 by 10 of A. So then what is the percentage change in A? It is a decrease of 70%. I hope you've understood it. This is not a decrease of 30%, because this is the multiplier fraction that we have obtained by subtracting another fraction from 1. And what was that fraction to get 3 by 10? That was 7 by 10. So the percentage decrease that took place was 70%. All right, when 42 is decreased by 16.66%, 16.66%, if you remember, we discussed that 1 upon 6 is 16.66%. So this is 1 by 6. There is a decrease of 1 by 6, which means that our multiplying fraction would be 5 by 6. 1 minus 1 by 6 will be equal to 5 by 6. So 42 will be multiplied by 5 by 6. What number do we obtain? We'll simply obtain it by multiplying 42 by 5 by 6, which is equal to, again, look at how simple this calculation becomes. It becomes 35. Otherwise, calculating with 16.66% would be so much harder. Okay, given that integer A is 25% more than B. So first of all, let's discuss what is this 25% more than B. What is our base over here? 25% of what? When we have than, more than B, we are comparing with B. Since we are comparing with B, our base is B. So this means that 25% is of B. Note what follows than. That is our base. So 25% more than B. 25% is 1 by 4. So 25% we know is 1 by 4. And so then the multiplying fraction will become 5 by 4 because we are increasing by 25%. So B into 5 by 4. This gives us an increase of 25% in B. And we are given that A is equal to this value. A is equal to 25 is, again, right? We discussed this. A is what? Equal to 25% more than B. That means 5 by 4 of B. We get this. Then B is what percent less than A? All right. So then let's put B in terms of A. This gives us B is equal to 4 by 5 of A. So by what percent was A changed to get B? This is your multiplying factor for A. We would have obtained this because it's less than 1. So we would have obtain this by decreasing a fraction from 1. So this is essentially equal to a into 1 minus 1 by 5. And 1 by 5 we know is 20%. That means B is 20% less than A. When we decrease A by 20%, then we obtain B. I hope this is clear. Okay, so now the last one. Given that integer A is 9 by 8 of B, B is what percent less than, let's take it up over here. So given that integer A is 9 by 8 of B. So B is what percent less than or more than A, which means B is equal to 8 by 9 of A. You'll just cross multiply, take it over there. All right. Now, what is 8 by 9? This is the multiplying factor for A. We decreased A by a certain percentage to get B. So this is essentially 1 minus 1 by 9. When we decrease 1 by 9, we get 8 by 9. Now, 1 by 9 is what percentage? We discussed that 1 by 9 is 11.11%. So when A is decreased by 11.11%, then we obtain B. So B is what percent less than or more than A? B is 11.11% less than A. To check that you're not making a mistake, when you have to increase by a percentage, make sure that you're multiplying by a fraction that is greater than 1. And in case you want to decrease by a percentage, make sure that you're multiplying by a fraction that is less than 1.